Hey, all right, 6-128. This problem says, give an example of an equation that requires the use of logarithms to solve it. So it hasn't really given us anything to solve. It just wants us to give an example. It doesn't even ask us to solve it. So let's just make sure that we are pretty clear of when we need to use logarithms to solve an equation. And most of the time, those types of equations that we're looking at here are exponential equations. We, we want to use logarithms many times when we're talking about exponential equations. And what I mean by that is we're going to have our variable is located in the power up in the exponent. So the variable is located in the exponent. So for instance, I can give you an example or two here just to make sure that we're, kind of on the right track. One type of equation or example, we could say there is, let's say 4 to the power of x plus 1 is going to equal 6. In this case, it's an exponential equation because our variable is located up here in the exponent. So in order to solve this, we're probably going to end up taking the log of both sides. And I'm just going to, include this tip here. So we take the log of both sides. In order to allow us to use the power property of logarithms. Abbreviate that and just put logs. So for instance there, if we wanted to do that, remember the power property comes into play where we're going to take it and we're going to do the log of each side. Remember, what you do to one side, you have to do to the other side. So we're going to say the log of 4 to the power of x plus 1 and the log of 6. So we've got that one here, and we're taking the log of this side. And that should still remain equal because we're doing the same thing to each side. And then that power property would then state that if we're raising some number to an exponent here, when we're taking the log, it's going to be equivalent to multiplying whatever that value that is in the exponent is 2 times our log. So we have the same thing here. This is an illustration of the power property of logarithms. In this case, there's nothing there, so we just have the log of 6 still. And then we can take it and we can divide each side by the log of 4. Just to isolate our quantity over here. And so x plus 1 equals the log of 6 divided by the log of 4. And then we'd probably subtract 1 afterwards. So x would equal log of 6 divided by the log of 4. Minus 1. So, you could calculate that. We're not really asked to go through and solve them here, but what I want you to focus on is when we have exponential equations, that's the time we want to end up using logs to help solve it. So another example, you could say, all right, well, if I have 3 to the power of x equals 10, same kind of thing here. We could take it and take the log of each side so that we could use that power property of logarithms. We could also do something like, just another basic example, 5 times 2 to the power of x minus 15 is going to end up equaling 30. Each of these here problems are very similar to the first one here in that our variable is in the exponent. We'd have to isolate the base with the exponent there and then be able to use that power property of logarithms. One that you will not use a logarithm to solve would be something where x is not in the exponent. For instance, if you had, let's say, 3x to the third equaled, say, 30. This would not use a logarithm. Because we already know what the value of our exponent. So this would not, so make sure we emphasize that this would not use it here. Anything like that would not use logarithms. These ones definitely would. These ones would. This one would. This one would. This one would not. So this is problem 6-128. Hopefully that helps a little bit with that if you had questions. If you have other questions about this problem or anything about logarithms, make sure you take the time to ask your teacher. Thanks for watching.